Hi, I'm João Lima, editor of Data Economy, and this is Frontline. Today we're talking about edge computing, one of the largest drivers in the market right now. And to learn more about that, I've got here with me Dr. Kevin Kettler, CTO of Flex, one of the largest technology manufacturers in the world. Kevin, thanks a lot for talking to me.
Thank you.
Before we dive into edge computing, your company has about 200,000 employees. That's a huge amount, more than many cities in Europe, for example. Right. How do you manage a company that big?
Well, quite honestly, we've got a lot of operations around the world with our global footprint, covering a lot of manufacturing sites. The ability, part of our value add is around the logistics and the ability to manage a global team of that size, especially when we're dealing with things like procurement, part procurement, as well as the manufacturing side of things that we're dealing with. So with the teams that size, we basically break it down into individual factories. Each individual factory then is treated almost like a business unto itself. And so it makes for the teams actually appear almost like entrepreneur teams unto themselves at each factory, at each site, and we're able to then bring that together at a corporate level.
So it comes down to your almost creating startup spirit in a large corporation.
Very much so, very much so. Each organization is very much entrepreneurial in spirit, as well as the ability to manage and define the products and the direction that the given manufacturing or development site is going to choose to pursue.
Okay, sounds good. And then on edge computing, because that's what you're here to talk for.
Right.
How is the cloud industry changing and adapting to edge computing? Because you've been doing this for a long time. You started at IBM, you've been to Dell, you've been to all these big guys as well. So
right.
How have you seen the industry changing over the years regarding edge computing, especially today? And even before that, if you could define what you mean by edge computing.
Yeah, I'll back up a little bit and give a little history lesson. I have been around a little bit, and if you look at the very early days, it was very much, this is very early days, batch processing type things. Then we moved to a new model of computing, and that was basically the movement to client server, just general client server. Then there was a shift as you moved into the 2000s to move into a cloud-based computing as a new model or paradigm shift. And I think the next wave that we're going to run through is the edge. We talk about the development of the edge computing model. When you look at that, there's a lot of drivers that are creating that. I always tie things back to business, the business and economics of what's causing that. So if you look, there's a lot of new application models that are coming to play with the advent of IoT, as well as 5G coming along, as well as autonomous vehicles. You'll also hear about smart cities. All these pieces are all coming together. They're being enabled. A key enabler is 5G with all this stuff. And then the notion of needing to go ahead and create compute that is closer to where the end user is actually going to be either consuming data, needing compute, or needing, in the case of 5G, low latency or high bandwidth response time. So my definition of edge is very much the notion of putting compute, storage, as well as intelligence very close to where a cell tower might be, as an example, distributed out to neighborhoods. So it's the notion of pairing it with the small cells associated with 5G.
Actually, you mentioned latency, and that's a very interesting topic. When we talk about edge computing, what sort of latency are we talking about? Are we talking about milliseconds, nanoseconds? Can you give an example with the driverless car?
Yeah, I'll give you examples. Let me kind of back up and I'll talk about 5G first, because I think that then feeds into the discussion around that. So if you look at the four pillars that I see with 5G, that are really defining that. The first pillar is the notion of higher bandwidth. The second pillar that you're going to get is low latency. And that lower latency is typically in the 1 millisecond or below latency. And that's response time relative to you going and making a connection, reaching the tower, getting a response back, getting an open line to go ahead and execute what it is you'd like to execute. The third piece is the enablement of IoT with 5G standards. The enablement of IoT actually falls into two categories as well. The first category is the notion of cells actually being able to handle thousands potentially of devices versus just a small amount of devices, like 50 to 75 devices that a traditional cell tower might have. And then the second part of that with IoT is the ability to do low battery life or low battery consumption to get extended battery life. So
which has been a bit of a problem until today.
Yeah, it has been. So what that creates is this market where you can have devices that might go 5 to 7 years on battery life. So if you look at that ecosystem, then you begin to say what applications can you now begin to develop that take advantage of some of these new technology advances that are occurring. And that's where you then start to see autonomous vehicles. You start to see that becomes a reality because now you've got low latency response time. You've got real-time applications that can run off the edge. You've got things like healthcare. You hear people talk about robotic surgery, where you've got a doctor doing robotic surgery, you need low latency. You can't always say, let me go ahead and have things flow the whole way back to the centralized cloud if you're looking for response. So that's all these pieces coming together really define edge computing on why you need this edge devices. And that's because that bandwidth, the greater amount of bandwidth, trying to push that the whole way back to the cloud, you need a lot of backhoes to drop a lot of fiber to take all that bandwidth back. The second thing you need to look at is latency. If you say, I just want quick latency, if you're going the whole way back to the cloud, you're now talking tens of milliseconds versus 1 millisecond. And then the notion of having so many devices, creating so much data with IoT, that just further enhances the need to go ahead and have this computing closer to where the data is being created.
And then, as you mentioned 5G, you're not the first one to mention 5G, of course, it's going to be very, very important. But right. 5G doesn't really, it's not out there yet. There's only some rollouts, especially in the Nordics, etc. Is it correct to say that edge computing cannot exist without 5G, or can we do it with 4G as we have now? Do we have to wait longer?
I think it's a transit. So it's one of those things that 5G will further enhance the need for edge computing. So I think there are cases today where edge computing is occurring. But if you look forward, when you move to 5G, it becomes very apparent in order to meet some of the base tenets that 5G is trying to bring to the table. You cannot go fully back to the cloud to deal with the amount of data that's being created and the latency effects that you're trying to overcome.
Okay, and as you're a man of technology, what can we expect from 6G, for example? Is it even correct for us to start talking about 6G? Do we need to go that fast? What does fast mean, actually?
Yeah, I think 5G is, there's still a lot of hurdles with 5G. We still don't have a spec in place with 5G that's finalized and ratified. A lot of countries are still working through spectrum allocation with 5G to enable 5G full deployment. There's just starting of trials with 5G. So I don't want to speculate too far on 6G because I know the teams are working so heavily on just getting 5G finalized. But I would expect 6G will improve upon a lot of the learnings that you have with 5G. When you're doing such a drastic shift from the notion of 5G, because 5G really adds a lot of different variables that you didn't have with 4G, 3G, LTE, things like that, this whole new set of applications and especially business models that will have to emerge around this, that will help define what it is we need to build into the spec for 6G. So I think it's still a little early on 6G. Like I said, 5G is still in its infancy.
Okay, and then 5G, this comes down to network operators, telecommunication guys, and they will have to work very closely to each other with data center operators. What's the value proposition here for telecommunication guys, and do you see them doing the right thing at the moment? Or do you see a lack in the market of understanding?
Well, I think the piece that really needs to emerge is what is the underlying business models that will come to play. Because if you break this down, you say you'll have potentially healthcare, smart cities, you'll have autonomous vehicles, you'll have the likes of Uber and others, you've got motor companies, and then you've got the traditional guys, the telco guys, you've got the compute guys, the cloud guys, and if you look at this, a lot of this is going to move, in my opinion, more towards a service-oriented industry. And then you say, well, who's the provider of the business service? And that'll really define how this comes together and rolls out.
It's down to everything as a service.
Yeah, well, it's historically you would have a number of individual verticals. So you would have a separate vertical for your telco needs. You have a separate vertical for your ISP, as an example, your internet service provider. You might have a separate account that you would deal with. That you deal with your car very separately today. You know, you just go buy a car, you have it serviced, you buy gas, you do things. You don't even think about how connected this needs to be going forward with when we talk about autonomous vehicles. So those shifts will all define very much the business models in play. And to your question of is it telco guys, is it cloud guys? I think when we talk about edge, what edge does is puts machines there near the edge of the tower. And those machines, if you think about those machines could be a number of different players, could be own that hardware or at least lease that hardware and put their services very close to where their customers are. And that's a business model that we have yet to see how that's going to evolve. And that defines who then pays for the infrastructure. Because I think that's what your question is. You know, when you spend all this money to go to 5G, somebody needs to recoup that cost. And how you do that business-wise is important.
Okay, so what's your view of the current developments in America, especially in America, with Vapor IO, Data Bank? All these guys, they're announcing deploying thousands of micro data centers next to cell towers.
Right.
Is this a good thing? Do you see it as a good thing? Do you see any issues with it? What's your thoughts?
Well, there's always issues when you you go through it. It's not issues in a negative thing. It's just you've got learning curves that they're all going to go through. The likes of Vapor IO and a number of these players that are building exactly for that edge. I think there will be a play for them. How that fits into the notion of a telco operator, again, it goes back to this business model, versus who owns the cell tower, who owns the spectrum flowing on through, will define then how much of this edge deployment occurs at what speed. It's not. I don't have a question that edge will eventually occur. It's at what speed will that deployment occur, and you also have this overlay of issues with local regulatory. When you say, okay, I need to...
This is quite a lot in the US as well.
Yeah, use the US as an example. If you look at the environment in the US, where you are now dealing with microcells, and the reason you have microcells is the technology, in order to get the bandwidth that you need and the latency you need, doesn't give you the spread of reach that historic cell towers have. So that's how you end up with many more cell sites than what you have today as you move to 5G, which then means you've got more infrastructure going in place, which means you've got to deal more with local government, state government, federal government, national issues.
Town hall government,
yeah, to get that all taken care of at each level as you're moving through. So those are. Is it insurmountable? No, not at all. It's just something that'll take time to get that rolled out. In the U.S. and in Europe, there's a number of trials that have already rolled out to deliver 5G. Most of that has been focused on. Most of that's been focused on the use of the cellular technology, but also using it as a fixed wireless access point. So effectively displacing what would be the last mile on an ISP to go ahead and provide that capability.
Okay. And as we talk about thousands and thousands, just to finish as well, this would be a massive task just to manage and keep them running and etc. So we have to look into new technology, and then we can dive into a little bit of into the future now.
Right.
So what do you envision in the future in terms of keeping up these sites working? So in terms of robots, nanotechnology, artificial intelligence, self-healing infrastructure and software.
Right.
What do you envision here, and what does Flex have to play in this space?
Well, if you look, the notion of 5 nines of reliability in remote sites, There's companies that deal with that today. It's not a new territory to go deal with that, but you basically end up building in the capability to have redundancy, the ability to go ahead and deal with catastrophic events like losing power to a tower. What does that do to everything? Do you have backup in a local edge compute to go ahead and keep power running, to keep the systems up and running? As you talk about reconfiguring, most people talk about things in terms of what large cloud compute guys do today, which is just building the redundancy into the system. So if you lose a drive, you lose a compute node, you just basically shift workloads, because everybody's using containers with their workloads. They just shift it to another set of devices, and things continue on with little disruption as they go through that.
Okay. And how's Flex going to play part in the edge computing revolution?
Yeah, well, we're in an interesting position because a lot of these things that I'm talking about, if you look at our business model, historically we've been a manufacturer. We're moving to doing a lot more development work with our partners, our customers. And the notion of how we're playing is we have a very interesting vantage point. We've got a whole division that's focused on the smart city side of things, the IoT enablement. We've got a healthcare business that's focused, that is working on IoT enablement of healthcare. We've got an automotive business that's working on autonomous vehicle enablement for our customers. And then, of course, we've got the core business, which is historically we've done a tremendous amount of business in the telco space, as well as cellular, traditional telco, as well as a big focus of our company in the last few years has been with the cloud players. So would I draw a map of all the things that we do? The map actually, it's a great view of what the industry is seeing with 5G and the emergence of edge and cloud. Cloud's going to continue to grow. It's not going to get displaced. It is just going to continue to grow. You'll now have edge as a new compute model, and you'll have 5G as an enablement of all that. So we plan on playing across all those spaces, and part of our value proposition is, earlier you mentioned 200,000 employees. Those are folks around the world in factories in different countries, in development sites. We've got over 2,500 engineers working on co-development with customers. That all comes together to help build this to go ahead and deliver value to our customers as we go ahead and put that together through our factories.
Okay, Kevin, thanks a lot for talking to me.
Thank you.
Don't forget you can follow Data Economy on Facebook, LinkedIn and Twitter, and also visit the website on www.data-economy.com.